In this section, we're going to talk about logarithms, particularly derivatives of logarithms and exponential functions. So if you thought you'd never see logs again after pre-calculus, unfortunately that's not the case. We are going to be using them here, and these are actually going to be very important for us when we take a look at some of the examples further on with derivatives. Let's review these first, and then I'm going to go show you a couple examples that illustrate these rules. The first one is when you have two things multiplied together inside of the log, you can break that up into two separate logs with a plus in there. Again, this is useful for derivatives because you might have something that's more complicated and it's harder to take the derivative because that would involve a chain rule, product rule, things like that. But you can break up the log into a plus, and then that'll make things easier because then you're doing the operations to each log separately. Likewise, if you have two things being divided, turns into subtraction, you can break up the log. Notice that all the bases here are the same. If this is log base A, then all the other ones have to be log base A as well. If you have 1 over y inside, turns into a negative log. It's easier to look at than in that form. And then this one, if you have an exponent, the exponent can actually be moved down in front of the log and turns into multiplication. So then it just turns into a constant that'll make that derivative easier to do instead of having it in the exponent position. So again, that's why you need to know these rules, because it makes things easier when we get into the derivatives. Let's take a look at these over here. So these are the algebraic properties of logarithms. These are the inverse properties. And we'll take a look at a to the x, and then we'll look at the ones for the log also. So here we have a log in an exponent position, but they both have the same base, the a and the a. So if you see that together like that, then the a and the log a essentially cancel and you just are left with x. Likewise, if you have an a to the x that's written inside of a log, so log a of a, if you see both those matching, again that's going to cancel and leave you with an x. We do have certain conditions here. A is going to be greater than 0, your a can't be equal to 1, and your x has to be greater than 0. So as long as that's true, these two properties are going to hold. Let's take a look at them for the ln. Now ln represents natural logarithm. It's a log base e. So it's basically the same as log base a, except that the a happens to be the e value here. If you have e and ln together, those are going to cancel out. That's going to leave you with x. Also, if you have ln e together, that's going to cancel, leave you with x as well. We have another condition here, x is greater than 0, and if you're wondering why we have that condition, it basically comes off of the graph. So in the notes section I do show the full graph of log base a or ln. It's basically the same graph. We're looking at the one specifically for natural log here, since we're dealing with them in property 2. And you notice that the domain is only talking about x values that are greater than 0. There's a vertical asymptote at the y-axis is your vertical asymptote there. So we're only talking about positive values for x. So because of that, that's why we have this certain condition. So now that we've gone through and reviewed all these different rules, let's take a look at a couple examples. So now that we've taken a look at the log properties, here's some examples to kind of illustrate some of them. The first one that we see there for a, this is going to use the algebraic property number 3 because we have a 1 over y. That says that we can rewrite this as negative log 3 of 3. And then you should also know that if you have this base and that base together, it's going to turn into a 1. But the reason why that happens is actually because of our inverse property number 1. It tells us that whenever this and this is the same, you're just going to end up with the exponent. And technically the exponent for 3 is 1. And so that's going to turn into, this whole thing cancels, leave you with a 1, and then you have negative 1 left over as your answer. Let's take a look at B. Now for this one, we have to do something first. We want to try and get the number that comes afterwards relating to 144. So here's something that you can do to rewrite it. We're going to leave the base as 144, but then we're going to change the 12 into the square root of 144. We know that the square root of 144 is 12, so we're actually just rewriting 12. We're not changing the problem by doing that. The power on here is a 1/2, so it means that this is log base 144 to the 1/2 power. So again, we can use the same property we just used for part A. That's the first rule for the inverse properties. That says that if you have this and this are going to match, that means that your answer is going to be 1/2. So that's the answer for B. It's 1/2 because you just end up with the exponent these two essentially are going to cancel. Let's take a look at C. Okay, now C is using the second property for the inverse ones. So if you have ln and e together, that means that you're just going to end up with the exponent. Now there are other ways of showing that. In the notes I did it by taking the exponent, bringing it down front. You bring that down there, and then ln e is 1 and it cancels. So you could do that as well, but it's probably easier just to use this property and you can get that in one step. Okay, so again, that's using the second property for the inverses. Okay, then this one, we're going to start by using property number 2 for the algebraics. That means that you want to combine this together first. So if you have two logs that are being subtracted, we can turn it into a single log with division. It's always the first one divided by the second one. So the rules that we had up there, you can actually go either direction. You can either expand it out to this, or you can take them and condense them back down into a single log. In this case, you wanted to combine into a single log. And then you have e and ln, that's the second property of the inverses. That cancels out and leave you with 6/7. So 6/7 is your answer there, and I'll circle this one as well. So these are all your answers for parts A through D.